Hey everybody, so real quick I just want to talk about metric conversions. It's good to have a quick refresher on that since we're going to be doing that quite frequently. So if we want to do basic metric conversions, we have a nice little table that helps us remember those, okay? It's split up into 7 groups with our center being our base, okay? And that's where we have our basic units of measurement, like grams, liters, and meters. Grams measures mass, liters measures volume, and meters measures distance. Okay, and then on these other ones we have kilo, hecto, deca, deci, milli, deci, centi, and milli, okay? Or if you would like to remember them a different way, I have my little memorization device. Kids hate dogs because dogs can't meow. So that's how I remember it. Kids hate dogs because dogs can't meow. And luckily, you'll never see hecto, you'll never see deca, and you rarely see deci. So mainly we're going to be doing things like going from kilograms to grams, liters to milliliters. Okay, you might see a centimeter to meter conversion here and there. So we're only focusing on kilo, base, centi, and milli. So I might have a situation where I might be saying, let's go from 4 kilometers to meters. So how many meters are there in 4 kilometers? So I got to figure out where I'm starting here, right? These are kilometers, and this is just meters. So what I'm going to be doing is I'm going to be going from my kilo section to my base section, which contains my meters. Well, in order to get from kilo to base, I got to go 1, 2, 3 spaces to the right. So 3 hops to the right. Okay, what does that mean? That means we're going to move our decimal 3 hops to the right. Okay, so I have that 4.0, right? From kilo to base, I do 1, 2, 3 to the right. So my decimal is going to go 1, 2, 3 to the right. So now my 4.0 became 4,000. That means that in 4 kilometers, there are 4,000 meters. Okay? You won't go from kilograms to milligrams. Okay? Usually, we have to try to get things into the grams, milliliters, or meters units. So let's do one of those ones where we're trying to go from liters to milliliters, but you'll have to do quite a bit. So let's say that we have 3.25 liters, and we want to go to milliliters. So again, we're looking at where we're starting. That gave us 3.25 liters. So we're starting in the base section, and this is lowercase m, uppercase L, which stands for milliliters. So we're trying to go from base to milli. In order to get from base to milli, we do 1, 2, 3 hops to the right. So once again, we're going to be taking our decimal, moving it 1, 2, 3 to the right, filling in any zeros we have there, and it ends up that there are 3,250 milliliters in 3.25 liters. Okay. If you want just times by 1,000, if you think that works, good, do that. Okay, I think it's easier just to move the decimal 3 to the right or 3 to the left. So let's do a situation where we move the decimal 3 to the left. Let's say I got, let's go with 53,000 millimeters, and I want to go to meters. Okay, try not to get these two m's confused. Remember, this is the milli, this is the meter, that's a meter. Okay, so we're trying to go from millimeters to meters, so we're starting at milli, and we're trying to get to our base. Well, in order to get from milli to base, you go 1, 2, 3 to the left. So we have 53,000. In this case, the decimal isn't stated. If it's not stated, it's always at the end of the number. And again, from milli to base, we go 1, 2, 3 to the left. So there ends up being 53 meters and 53,000 millimeters. Okay, so in this situation, if you want to divide by 1,000, that's fine. I think it's just easier to move it 3 to the left. All right, so let's get into our next thing from basic chemistry, which is scientific notation. Scientific notation is just, it makes it easier for us to write really big and really small numbers. In chemistry, we deal with trillions and trillions of atoms, so sometimes it's easier just to write things in a shorthand form, and we even deal with really, really small numbers like wavelengths of color, so we might have to figure out a shorthand way to write a really, really big number or a really, really small number in a more concise space. So, example of that. So again, we are talking about scientific notation. So you might have something like a number like 1 million. Okay, it's a pain to write all those zeros. So a shorter way to write that is just to make it 1.0 times 10 to the 6th. Okay, we might have a number that's really small, like 0.000001. Again, that's a really big pain to write out all those zeros. So instead, you might write something 1.0 times 10 to the negative 6. Okay, so I'll explain how to do that. Our first main basic thing is that we have to move the decimal around. Okay, so we'll have to move this decimal and we'll have to move this decimal. Where you move it is important. Okay, standard scientific notation. When you move it, you only want one non-zero number to the left of it. Okay, so as you can see, when I move this decimal, I didn't stop here and make it 10 times 10 to the 5th. I kept going until there was only one non-zero number to the left. So I made it 1.0. Okay, let's do an example with that. So say I have something like 35,000. Okay. Now the decimal's right here, and I want to move it so there's just one non-zero number to the left of it. So I'm going to move it to the left. 1, 2, 3. I'm not going to stop here because I still have two non-zero numbers to the left of it. I'm going to go right here. Now I have only one non-zero number to the left of it. Okay, I only have that 3 to the left of it. So now my new number is 3.5, but I can't stop there, right? Because 35,000 doesn't equal 3.5. I got to show that I moved that decimal. So now I put times 10 to a certain exponent. Well, that exponent is just going to be how many digits or how many decimals you moved, how many places you moved the decimal. Okay. In this situation, I moved it 1, 2, 3, 4 to the left. So my exponent is going to be 4. Okay. To determine if it's positive or negative, if you move it to the left, the decimal to the left, that means that your exponent is going to be positive, like what happened here. Okay, if you move it to the right, the exponent's going to be negative. Also, just check your answer, right? What's 3.5 times 10 to the 4th? 35,000. If you did 3.5 times 10 to the negative 4th, you would have ended up with something like that, okay? And then you know you got the wrong sign on your exponent. So, just like with this guy, up here, we move that decimal 1, 2, 3, 4, 5, 6. Now I only have one non-zero number to the left. So I put a 6 up there, but since I put the decimal to the right, okay, I had to make sure that my sign was negative. Okay, let's do another one like that where it's 0.0305. Okay, so again, I want to move my decimal just so there's only one non-zero number to the left of it. I'm going to take that decimal and I'm going to go 1, 2. Okay, I can stop right there. Now I have just one non-zero number to the left. So now my new number is not 0.0305, it's just 3.05. Okay, but I can't just leave it at that. I gotta let you know that I moved that decimal. So it's going to be times 10 to the, I moved it 2 spaces. Okay, But I'm still not done because I didn't move it to the left, I moved it to the right. And if we move our decimal to the right, our exponent's gotta be negative, right? So again, you could double check your answer, okay? And you plug that in, it'll give you your original number of 0.0305. If you tried getting 3.05 times 10 to the second and plug that into your calculator, that would have given you 305. So you would have known that that was incorrect, okay? One last thing to tell you, and this is just a suggestion. It's something you have to do or else you're going to get wrong answers, but it's just a reminder, I should say, is that when we are doing calculations, especially when you are dividing numbers in scientific notation, make sure you put them in parentheses. So if I give you a problem like 1.06 times 10 to the negative fourth divided by 3.24 times 10 to the fifth, make sure that when you put those in your calculator that you put them in parentheses. If you don't, you're going to get a super weird number. The order operations are going to be wrong and you're going to get a really, really big exponent. So make sure you're double checking your answer and seeing that it makes sense with the numbers that you started with, right? Here you should get something to the negative 9th, negative 8th, negative 10th, somewhere in that range, okay? So again, make sure that you put them in parentheses when you plug that into your calculator, guys. Have a great day.